these videos, we are going to use the same branches that we've just learned. So branch always, branch on positive, and branch on zero. But instead, we're going to use them for iteration instead of selection. So that's going to be our loops where we're repeating code. So same ones, like I said, but we're going to look at some different code this time. So here, we input a number. We're going to output that number. Fine. We're ignoring this label because we're just going to run the line of code after it because we've gotten to it sequentially. So we input output, we subtract 1, we output that, we branch on positive to start. So in this case, it's going to jump backwards, and that's how we know it's a loop, because in the previous ones, we always jump down for our selection, but here we actually jump backwards, and that's our loop. And so if it's positive, we come back to start, where we subtract 1, output, and if it's still positive, we go up to start, and this continues, this loops, until it is less than 0, because remember, branch on positive includes 0. So when we get a negative number, it will halt, and that's our code. So what this will do is has a user input a number, and it will count from that number down to -1 inclusive. So for example, if they input 3, 3 is in the accumulator, and then we output 3 on line 2. We subtract 1, which puts 2 in our accumulator, we output that, and then on line 5, right now 2 is in the accumulator, so we jump up to start, where we subtract 1, so 1 is in the accumulator, we output 1, 1 is positive, so we jump up to start, where we subtract 1, we output, we're at 0 now, 0 still counts as positive, so we jump up to start, where we subtract 1, we output -1, -1 is not positive, so then we halt. Now, this is good, but oftentimes we want to count down to 0 instead, so let's think about how we could do that. So here, the code is the exact same, except we've got this extra branch on Z to end. So what this is going to do is the start will still branch. We've still got our loop here, but this time when we'd outputted 0, and that's probably where we actually wanted to stop. But because 0 was positive, we had to branch on positive back up to start. Here, when we get to 0, because it's 0, we're going to jump to the end where we're going to halt. Okay, so when we trace this out, if we have 3, we still do the 3, 2, 1, 0, and that's the same as last time, so I'm not going to go through that again. But every time on line 5, notice we never actually run it, but on line, nothing changes, but on line 5, we're checking every time if it's 0. And then this last time when it is 0, we can jump down to the end and halt our program. So it allows us to finish when we want to. And you'll see this combination a lot of the BRZ before the BRP, because that BRP obviously includes 0, and sometimes we need to separate the two out. So if we want BRP to only be numbers greater than 0, so positive numbers greater than 0, putting a BRZ before it allows us to do that. Last example here. So we are going to start, we're going to input a number, we're going to add that number to our total, we're going to add total to that number, and then we're going to store the value in total. We're going to output it, we're going to subtract 50, branch on positive to end, otherwise, and that's going to end it, otherwise we're going to come back up to the start. So what this does is the user will input numbers and it adds them to a total. When that total is at least 50, it's going to stop. So let's have a look. So we need to update that. So we start off with 30, all right? So 30 is inputted. We add on our total. Sorry, when we add total, the total starts at 0. So when we add total, it's still 30. And that's why I need to do line 2 there. And then on line 3, we store that back in total. So total is now 30. I'm going to output my total. Okay. I subtract 50. And what this bit here is doing, the subtracting 50 and branch on positive to the end, that's trying to find out if we've hit 50 yet. So 30 take away 50 is -20, which is not positive. So we don't end and we keep going. So we know we're less than 50, and that's why we continue. So we're going to come back up to the start where we input another number, which in this case is 12. We're going to add our total, so we get up to 42, and we store that back in our total. So this is that running total algorithm, where our total is now 42. We output that total, so it's outputting every time. We subtract 50, we're still negative, so we know we haven't reached 50 yet. So we don't end, but instead we loop back up to the start, where I input another number, 14 in this case. We add total, 56. We subtract 56, we store that back in 56. We output it, and then when we subtract 50, we're at 6. So because it's positive, I'm now going to jump down to the end. So notice now when I jump, it comes down. So that loop is over where my program halts. All right, for our example here, let's do this one. So this is a bit different than the other ones we saw, but it's similar to that running total algorithm, that last one. So keep reading numbers until 0 is entered, print how many negative numbers were entered. So you can see some examples here, but we're just counting the negatives until 0 is entered. So in Python, this would be a running total algorithm. Same logic here, but we're just going to code it a bit differently. So let's start off by inputting a number. Now, if they input 0, we need to stop straight away because that's like our while loop. So we're going to say BRZ to end, okay, and we'll write that end label later on. All right. Now, if the number they've inputted is positive, we already know it's not 0. So, but if it's positive, we don't need to do anything, right? We're only counting the negative numbers. So we can BRP to the loop, and let's label that loop. So that'll just come right back up to the beginning. So if it's 0, we end. If it's positive, we come back up to the loop. But if it's negative, we need to add on to some kind of count. So let's create a variable count, and it'll start at 0. So I'm going to load my count into the accumulator. I'm going to add 1, so I need to make that 1 variable as well. And then what I've basically done here, that's the Python equivalent of count plus 1. But of course in Python, what I actually need is count equals count plus 1. So to do that, I'm going to store that back in count. So I've loaded count, I've added 1 to it, and I've stored it back in count. And now, we already know the number inputted wasn't 0, otherwise we would have ended. So I'm going to branch always back up to my loop. So let's say I input 5. It's not 0, but it's positive. I don't need to do anything. Comes back up to loop. I enter negative 10. It's not 0. It's not positive. So I load my count. I add 1. I store it back in count. And then I'm going to come back up to the loop so that they can input another number. Now, when they do finally end, so that's going to be my end label, I need to output my count because that's the whole point of this, is to print how many negative numbers were entered. So I'm going to end. I'm going to load my count. I'm going to output it, and I'm going to halt. All right. So let's test this. If I input 3, good. It hasn't done anything. It hasn't added to my count. If I input negative 2, my count is now 1. So that's that. It loads count, it adds 1, and then it stores it back in count. If I do negative 9, it is going to load count, add 1, and store that back in count. 7 does nothing, right? It just puts it in the accumulator, and then 0 to end. And it's counted 2 because I inputted negative 2 and negative 9. So it seems to have worked correctly. Let's check our answer, and we are good to go.